So today I'll be talking about some of the techniques we use to model fraud at new data. So we use various different techniques for modeling fraud, but one of the principal machine learning techniques that we use is known as gradient boosting. So this technique belongs to the class of decision tree based models. So before I explain gradient boosting, it makes sense that I go over decision trees first. So if you have played the game 21 Questions, you may be familiar with a decision tree. This is how the game works. So let's say you have two players. The first player has some sort of an object in mind, and the second player tries to guess that object correctly by asking the first player up to 21 questions. And then the first player responds by saying yes or no until the second player runs out of 21 questions or the second player has guessed the object correctly. So that's essentially what represents a decision tree. Now, decision trees have various applications. They're used for decision making in business and finance and math, etc. And they're also really good for classification. And for that reason, we used to classify fraud. For machine learning, the way we construct decision trees is by giving it some input, also known as machine learning features, and an objective function. Inputs are data about user behavior, biometrics, information about users' login frequency, their recency, familiarity of their location, and so on. And then the objective is to construct a tree that can optimally create branches to evaluate fraud and non-fraud records. So building one tree is generally not good enough from a model robustness perspective. Similar to a coin flipping experiment, if you flip a coin just twice, it's generally not good enough to say whether the coin is fair or not. So we can build multiple trees and then take the average output amongst all these trees. A better method yet would be to use a technique called gradient boosting, where we iteratively build hundreds or thousands of these trees by giving more weight to weaker trees along the way in order to create stronger trees or stronger learners. And then to evaluate this model, a record goes through these thousands of trees before getting assigned a fraud or not fraud label. At a high level, this was one of the techniques we used to classify fraud at new data.